It's time for geologic time. This is video intro 2A.1, whether you're in my Geology 1 class or my Geology 3 class. Now, I've put this cartoon picture here of the Flintstones just to represent a misconception that's very, very common, and I hope that by the end of this series of videos you'll agree with me that it's a big mistake. Humans and dinosaurs did not live at the same time. In fact, there's about a 65 million year time difference between when the dinosaurs went extinct and when humans are first found in the fossil record. So I just put that there. Some things I want you to think about as you watch this series of videos about geologic time. What determines when various geologic time periods begin and end? What was the Cambrian explosion? How does the age of Earth compare to the time when humans appeared? And when did the most recent ice age end? And we'll come back to these questions at the end of Unit 2A. I need to introduce you to the fact that we're going to be using millions and billions a lot in this class, especially when we talk about the age of the universe and the age of the Earth. If you recall from the video about the metric system and some of the prefixes, you've already seen kilo and mega and giga. I didn't really emphasize those last two, but these are abbreviations for thousands, millions, and billions. These prefixes are attached to the word annum, which is Latin for year, and so 1,000 years, million years, billion years is what these stand for. Now, I think you're pretty aware that there are 3 zeros in 1,000. Some people are a little shaky on their millions and billions. Remember that there's a 1 followed by 6 zeros for a million, and a 1 followed by 9 zeros for a billion. Notice also these abbreviations, Ka, Ma, and Ga. We're going to be using Ma, millions of years ago, and Ga, billions of years ago, a lot in this class. So I want you to get used to these concepts. Now, here's a question for you. How many millions are in a billion? Pause, go back to the previous slide if you need to, and think about the answer. Okay, here's the answer. 1 billion equals 1,000 million. There's 3 decimal places difference between them. And so if we use our terminology we just learned, 1 Ga equals 1,000 Ma. Now you might be wondering, why are we learning this? Well, it's because, again, we often talk about millions of years in geology interchangeably with billions of years. So I want you to get used to that. For example, the Earth is 4.6 billion years old, something that you should memorize right now. I probably will ask you on every test. So how many millions is that? Go ahead and pause and see if you can answer that question. And also the next question, 4.6 billion years, how could you write that out with all the correct number of zeros? Okay, here come the answers. 4.6 billion years is 4,600 million years. And with the correct number of zeros, it looks like that. Okay, let's move on to geologic time. Now, I asked you to print out a copy of this. This is from your online geology textbook, and hopefully you have a couple copies so you can take notes directly on it. I think it will be easiest. If you didn't do that, you might want to pause and print those out right now. If they're in black and white, that's fine. So what you can see here is 2 different time scales. And on the left, we've got all of geologic time, and geologic time scales always show the past at the bottom and the present at the top. And so this is the beginning of the Earth history, and this is today. And then what's shown on the right column is a blow-up of the most recent geologic time in more detail. So what we're going to do is first we're going to look at the whole geologic time scale, and then we're going to focus on the more recent part of the time scale. So focusing now on all of the time scale, and I'm going to blow it up here. Well, this at the bottom is 4,600 million years ago. And I apologize for that being cut off, but that says 4,600 MA. And at the top we have the present. So Earth history is divided into different chunks of time, and the largest chunks are called eons. Just like time is divided into centuries, which are divided into smaller parts called decades, which are divided into smaller parts called years. And there are two eons that I'd like to show you now. The Phanerozoic is the one that we live in, and that means visible life. So zoic is an ending that you're going to find commonly in the geologic timescale. That means life, like zoology, life. And then phanero refers to visible. The other eon is the Precambrian, and I'll explain in a little bit where that name came from. But this is basically the first 4 billions of years of Earth history. Now, the Precambrian is also divided into 3 sort of sub-eons, the Proterozoic, the Archean, the Hadean. We're not going to worry about all of this stuff going on back here. We don't have time, and we're more interested in what's been going on in the past 500 million years. So on that note, what is the time that divides these 2 major eons? Well, it happens to be 542 million years. At that point in time in the past, we changed from Precambrian to Phanerozoic. Now, why would we do that? Why would we not just choose a nice round number like 500 or even 550? Well, I'll get to that in just a bit. Now, one thing about this visible life, this does not mean that the first fossils showed up 542 million years ago. It means that fossils with preservable parts like shells and teeth suddenly showed up in the fossil record abundantly for the rest of time since the beginning of the Phanerozoic. The oldest fossil, in fact, is way, way, way back here in time. 3.8 billion years old, or 3,800 million years old. They're called stromatolites, and this is an artist's depiction of what they look like. Basically, they were blue-green algae that lived in shallow water. You're not actually seeing organisms in this picture. What you're actually seeing is their house that they're building out of limestone. So the blue-green algae are layered in there, and they're building these mounds higher and higher and higher, and the living part is at the top. Now, we actually have stromatolites living today. Here are some stromatolites in Sharks Bay, Australia. So this oldest fossil is pretty resilient. I'm going to show you a stromatolite that I have. It's a paperweight, I guess. And if I get the light right, you can see that there are wavy layers if I go around. And this is a side view, a cutaway view of these creatures that built upward. And again, most of this is limestone. It's their house that they built. If we look at the top, you can see it looks like we just cut a bunch of domes. So now we're going to concentrate on the most recent eon, the Phanerozoic. So again, here's the double column, and now we're going to focus in on this most recent Phanerozoic eon. So just like before, I'm giving you where the present and the bottom of this timeline is, 542 million years. And eons are divided into smaller pieces called eras. And here we have the Paleozoic era, which means ancient life, the Mesozoic era, which means middle life, and Cenozoic era, recent life. Eras are further divided into periods, and some of these geologic periods you might have heard of. Jurassic period, you probably have all seen Jurassic Park, or Jurassic Park 2, 3, 4, 5, I don't know how many there are by now, but that's a big time of the dinosaurs, and actually the entire Mesozoic was. But the earliest geologic period in the Phanerozoic eon is the Cambrian. And so that's why the previous eon is called the Precambrian, because it's all that time before the Cambrian. So now getting to this weird number of 542 million years. That number is the beginning of this eon because it was the time in the fossil record that we see the Cambrian explosion. Now, this is not like a boom Cambrian explosion. This is a sudden appearance of fossils with hard parts, such as shells, in the worldwide rock record. Everywhere around the world at this time period, we suddenly see organisms with shells. And as I've mentioned earlier, this continues for the entire time period up to the present. So this was a very important time, and that's why they decided to make it a brand new eon. Coming up next, we're going to focus on the Phanerozoic, which is fairly recent given the age of the Earth, the past 500 million years.